Imagine if stars, those distant twinkling lights scattered across the night sky, are more than just burning gas. What if, instead of being simple balls of hot plasma, they hold secrets that challenge everything we think we know about life and the universe? What if, in some sense, they're alive? It sounds wild, almost like something out of a dream or a fantasy. But sometimes the universe is stranger than fiction. This isn't just science fiction. The idea that stars could possess qualities of life has inspired countless stories, but it's also sparked real scientific curiosity. Some astronomers and physicists are seriously exploring whether stars show behaviors that mirror life. They're asking, can something so massive, so hot, and so seemingly simple actually be complex in ways we haven't yet understood? Stars are extreme, surface temperatures in the thousands, cores in the millions, and nuclear fusion forging the elements of the universe. They are the cosmic engines that make life possible, creating the very atoms that make up our bodies and our world. It seems like the last place to look for life, but maybe we're not using the right perspective. Maybe life as we know it is just one version of a much bigger story. When we think of life, we picture cells, DNA, and water. But what if life could exist in forms and places we've never imagined? What if complexity and self-organization are the real hallmarks of being alive? The idea isn't that stars have aliens on their surfaces, but that their complex systems and feedback loops might qualify as a form of life. Stars regulate themselves, adapt to changes, and even die in spectacular ways. Stars process energy, maintain stability, and evolve over billions of years. Traits we see in living things. Their life cycles are dramatic, from fiery birth to explosive death, and each stage is a story of transformation. So, let's set aside our Earth-centric views and look at the night sky with new curiosity. What if the universe is teeming with life, not just on planets, but in the stars themselves? We'll explore what makes a star tick, what defines life, and where those ideas might overlap. The answers might change how we see our place in the cosmos. This isn't about answers, it's about asking the big questions that expand our cosmic perspective. So as you gaze up tonight, remember, the stars above might be more alive than we ever imagined. To consider living stars, we need to know what a star actually does. When we look up at the night sky, we see thousands of tiny points of light, each one a distant sun. But what's really happening inside these brilliant objects? What makes a star more than just a glowing ball in space? A star is a cosmic power plant, a self-regulating nuclear reactor. Deep within its core, unimaginable forces are at work, driving the processes that allow it to shine for millions or even billions of years. Unlike anything we can build on Earth, a star's energy comes from the fusion of atoms, not from burning fuel. It starts as a cloud of hydrogen and dust, pulled together by gravity. Over millions of years, these clouds collapse, growing denser and hotter at the center. This is the birthplace of a star, a process that happens in the dark, hidden nurseries of space, where new stars are born from the remnants of old ones. As the core heats up, nuclear fusion ignites, fusing hydrogen into helium and releasing immense energy. This energy radiates outward, traveling from the core to the surface, and eventually streaming into space as light and heat. The process is so powerful that a single star can outshine entire galaxies for a brief moment in its life. This energy pushes outward, balancing gravity's inward pull, a delicate equilibrium that keeps the star stable for billions of years. If the balance tips, the star changes. It can expand, contract, or even explode. This constant tug-of-war is what allows a star to maintain its shape and size for so long. As stars age, they fuse heavier elements, creating carbon, oxygen, and even iron in massive stars. Each stage of a star's life brings new changes, new elements, and new possibilities. The heavier elements formed in stars are scattered across the universe when stars die, seeding new generations of stars and planets. Nearly every element in your body was forged in a star. The calcium in your bones, the iron in your blood, the oxygen you breathe, all were created in the hearts of ancient stars that lived and died long before our solar system was born. So, a star isn't just a ball of fire. It's a dynamic, self-sustaining system creating the building blocks of the universe. It is a complex engine, constantly changing, adapting, and influencing everything around it. It takes in fuel, processes it, and maintains stability against gravity. This ongoing cycle of energy production and balance is what allows stars to exist for such long periods, shaping the universe as they go. This self-regulation is why some scientists see parallels between stars and life. Like living organisms, stars respond to changes, adapt to new conditions, and even have life cycles of birth, maturity, and death. Stars are factories, power plants, and creators all in one. They manufacture the elements, power the galaxies, and create the conditions for life to exist. Their life cycles shape the cosmos. From the smallest red dwarfs to the most massive supergiants, every star plays a role in the grand story of the universe. Understanding this is key to the question: could stars be alive? By exploring how stars work, we get closer to answering one of the universe's most intriguing mysteries. What does it mean to be alive? On Earth, we use a checklist: growth, reproduction, response to environment, metabolism, and homeostasis. But is this the only way to define life? What if life can exist in radically different forms? If we stick to our definition, stars aren't alive, they don't reproduce or have DNA. But if we focus on complexity, energy processing, and maintaining order, stars start to fit. Like living things, stars take in low-entropy fuel and release energy, maintaining structure against chaos. The question is, are stars just analogous to life, or could they be a genuine different form of life? Some scientists argue that life is about organized complexity, not just chemistry. Maybe stars are alive in a way we're only beginning to imagine. Let's look at a star's metabolism. Instead of biochemistry, stars use nuclear fusion, processing hydrogen into energy and heavier elements. This isn't a simple burn, it's a dynamic, self-regulating process. If fusion slows, gravity compresses the core, heating it up and speeding fusion again, a feedback loop or stellar homeostasis. Inside, giant convection cells move plasma, transporting energy and mixing elements, like a circulatory system. Magnetic fields generated by plasma motion create sunspots, flares, and ejections, complex behaviors, not random events. These feedbacks and flows keep the star stable and evolving. The star's interior is a hotbed of activity with plasma, gravity, and magnetism in constant interplay. This complexity rivals that of living organisms. Stars are far more than inert balls of gas. Their intricate systems invite us to rethink what life can be. The night sky is filled with stars, but they're not all the same. When we look up, it's easy to imagine that every star is just a tiny, distant sun, but the reality is far more fascinating and complex. Our galaxy holds hundreds of billions of stars, each unique in size, color, temperature, and life story. Some are so faint they're nearly invisible, while others shine with dazzling brilliance, visible across vast distances. There are tiny, long-lived red dwarfs, the most common type of star in the universe. These stars burn their fuel slowly, glowing with a gentle red light for trillions of years, far longer than our sun will exist. Then there are stable yellow stars like our sun, which provide warmth and light to their planetary systems for billions of years, creating the conditions for life as we know it. And at the other extreme, massive blue giants live fast and die young. These stars burn through their fuel at a furious rate, shining intensely blue and white, and often ending their lives in spectacular supernova explosions. Some stars pulsate rhythmically, expanding and contracting in a cosmic heartbeat, while others flare unpredictably, releasing bursts of energy into space. Many stars exist in pairs or groups, locked in a gravitational dance that can dramatically influence their evolution. These stellar partnerships can lead to exchanges of material, or even dramatic collisions that reshape their destinies. This diversity mirrors the variety of life on Earth, different strategies for survival and cosmic roles. Just as animals and plants have evolved to fill every niche, stars have developed their own ways to thrive in the universe. Red dwarfs focus on longevity, quietly burning for eons and outlasting almost every other type of star. Blue giants, on the other hand, burn bright and hot, living short but influential lives. When they die, they explode as supernovae, seeding the universe with heavy elements that become the building blocks for planets and even life itself. Each star's path is shaped by its mass, its companions, and the environment in which it forms, whether in dense clusters, swirling nebulae, or the quiet outskirts of a galaxy. If stars are a form of life, they've diversified into countless types, each with its own strategy for shining, surviving, and transforming the cosmos. This variety enriches the universe, creating a complex web of interactions where the birth, life, and death of stars shape galaxies and influence the fate of everything around them. Stars play different roles in the cosmic ecosystem, From nurturing planets to forging the elements that make up our world, their diversity is a clue to the universe's creative power, reminding us that even in the vastness of space, variety is the rule, not the exception. The biggest barrier to seeing stars as alive is our Earth-centric mindset. We're used to carbon-based life in water, so a star's plasma seems impossible for life. But why limit life to our chemistry? The universe may host forms we can barely imagine. Life could be based on silicon, methane, or even plasma and magnetic fields. A star's thoughts might be magnetic fluctuations, its metabolism nuclear fusion, its lifespan billions of years. Such life would be utterly alien, so different we might not recognize it. Maybe life is defined by behavior and complexity, not building blocks. Any system with enough complexity and energy flow could be alive. On Earth, that's biochemistry. In stars, it could be something else entirely. The principal self-sustaining complex systems may be a universal constant. If stars have a metabolism, could they have something like a nervous system? In us, nerves transmit information. In stars, it's the magnetic field. This field, generated by plasma motion, is dynamic and complex, linking the star's core to its surface. Magnetic activity transmits information, coordinating the star's behavior. Solar flares and sunspots are not random, they're the star's way of regulating itself. The sunspot cycle hints at long-term coordinated processes. Could this be a form of stellar cognition? Maybe not consciousness, but a kind of information processing. The magnetic field acts as the star's global nervous system. There's a profound, factual link between stars and life. We are made of stardust. The atoms in your body, carbon, oxygen, iron, were forged in ancient stars. When massive stars die, they scatter these elements across the cosmos. New stars and planets form from this enriched material. Earth and its life arose from the remnants of long-dead stars. We are literally the children of stars, connected by a shared ancestry. This blurs the line between living and non-living. Stars create the ingredients, planets use them to build new complexity. The universe is a unified, evolving system. Looking at the stars is looking at our cosmic family tree. So are stars alive? It depends on how we define life. If we stick to biology, the answer is no. But if we see life as complex, self-sustaining systems, the question becomes fascinating. This debate pushes us to rethink our place in the universe. The cosmos becomes a vibrant ecosystem with stars as active participants. Our own life is just one expression of the universe's drive toward complexity. Whether or not stars are alive, pondering the idea expands our sense of wonder and connection. The universe is more mysterious and magnificent than we imagine. And maybe, just maybe, the next great revelation is shining above us every night.